Hi everyone. In this chapter, we're going to it's an introduction chapter. So we're going to introduce these models very, very gently, and build a foundation which we'll use later on. We did say that large language models, they are deep neural networks. These are deep neural networks. So I'll just be writing main points here that I want to emphasize. And if you recall, we actually have a branch of AI. This is the branch which is AI. And inside AI, we have machine learning. We have machine learning inside AI like this. And inside machine learning, we have deep learning. Deep learning like that. And where generative AI or where these models sit, they sit in like these LLMs, they sit inside here, inside deep learning like this. Because they're a special branch of deep neural networks. And if we now want to show where large language models are, generative AI is around here. This is now Gen AI. It's now generative AI. Some generative AI is not some generative AI is not LLM, or they're not based on LLM architectures. But that's where generative AI is. Some generative AI, they're large language models, some are not. So that's where Gen AI actually sits right there. And because these are deep neural networks, they need to be trained. And they're trained on vast amounts of data. They're trained on vast amounts of data. Sometimes it is data that is equal to the whole internet, sometimes. The whole internet, especially the foundation models that are coming from the top research labs like your OpenAI. They're complaining that they are running out of data to train these models on. So they are venturing into some called synthetic data or fake data that looks real, that feels real, but is generated by other models. And they are called large language models. The large in them is because of the number of parameters that they have, number of parameters, and of course because of the data that they are trained. The data that they're trained on is very large. It's a large amount of data. But the number of parameters, it is not surprising to see that number of parameters go up all the way to 100 billion plus parameters, or they can be close to trillions of parameters. If you were paying attention recently, as of recording this video, there was a model released from China called DeepSeek, and DeepSeek R1. And this model is, I think it is 671 billion parameters or something like that, or close there. So let me just put approximately 671 billion parameters. And I think 37 of them are active all the time. 37 billion are active all the time. This is a concept that is beyond the scope of this course, where you talk about something called mixture of experts. We're not really going to get into mixture of experts, but just imagine 600 billion parameters. When you did maths in high school, we did something like y is equal to maybe beta naught plus beta 1 x1 plus, or they are way up to maybe like beta p xp, right? Because you're doing regression. So these betas here, those are parameters for that particular regression. So here we just have p plus 1 parameters, p parameters plus this one here. Some people call it the bias, some people call it the intercept. So here we have p plus 1 parameters, and usually it's so rare when you're doing this to deal in hundreds of parameters. Usually just deal with manageable 20, 30, or whatever it is. Now think about 671 billion parameters. That is large. There's a large number of parameters. And the way we are going to train this model, or the way these models are trained, especially the foundation models, is they they are trained such that those weights that they have are optimized to do what is called next word prediction. Next word prediction. So when given this next, they will predict word. When given these two next word, they'll predict prediction. So going forward, like you can say, stage one, we give it next, and then it will its prediction will be word. And then in phase in number run number two, they're given next word, and then the prediction that comes out is prediction. Is prediction. And then in the third run, we give it next word prediction, and then yeah, to predict maybe something like it's an end of sentence. End of sentence. The sentence is finished. That's what they'll predict. Don't worry about these tags. We are going to discuss all of those tags, and we are going to discuss the principle of how it does this next word prediction. We are actually going to train a model that does the next word prediction. We're going to first start with a model that doesn't even know how to do the next word prediction. It might say next, and yeah, it will predict something like something next. It will say maybe photosynthesis, and then here to say computer, because it hasn't been trained yet. It hasn't been trained yet. It doesn't know how to predict the next word. But after we have trained it, it would then write a coherent sentence that makes sense to do this next word prediction. This next word prediction, it makes sense because if we can do that, if we can predict the next word correctly, we can harness the inherent sequential nature of language and use it for other means. So we use it for other means. Now we get to, if we want to predict, um, um, if we want to predict things like, if we want to classify an email, this next word prediction can be fine tuned to then be a classifier, which makes it this simple task actually very, very, very powerful. Produces these powerful models. Some researchers are actually surprised that just by training these models to predict the next word, we can build models that do amazing things like classifying emails, like doing semantics, like finding semantics and all of that, which is incredible because them just understanding the structure of the data that we give it, being able to predict this can lead to models that we use every day in your chat GPT. The way we are going to also discuss how they do this is by what is called attention. It's what is attention. So when given an input, the model will selectively pay attention to different parts of what it has been given. Because we can give it a paragraph with words. The model itself will, for it to properly predict the next word, it will selectively choose what it wants to pay attention to in the input sequence. So you give it an input sequence, it will selectively pay attention. It will say, okay, I'm going to pay the most attention to this that says London. That says London. And maybe another one will talk about is. It will pay more attention to this part. Yeah, it could be city of. It will say, okay, I'm not going to really pay attention uh, to to those parts. I'm just going to pay attention to London and the word code is, and I'm going to predict the next word to be beautiful based on this attention mechanism. And we are going to see how the attention mechanism will work. Because these LLMs can generate text, they are also often referred to be part of generative AI. Because they're generating the text with that next word prediction, so they are part of generative AI or Gen AI in short, as we call them. Gen AI. Let's see, we're just taking a look at my notes here. Um, so how we are going to train it as well, after giving it this input text, we are going to look at performance metrics. as we train it. As we train it, because when it starts, it's not performing well. It's saying next for the synthesis computer, that is bad performance, bad performance. But once we train it, we'll be keeping track of some performance metrics until they get to a level where we are happy that it has been trained well by keeping track of the performance metrics. And when we use it, we hope that it would have done proper next word prediction. The error that comes out first when we do next photosynthesis computer, there is an error term that we are going to keep track of, or there's an error that we are going to keep, not error term, let me just say there's an error that we are going to keep track of, and we want to minimize this error. We're going to minimize the error. By minimizing the error, we're actually training the model to do good next word prediction. So that's how you train models. That's in machine learning. In machine learning, when you're training a machine learning model, you're minimizing the error. You're minimizing the error signal, or you're minimizing the error. As you minimize the error between what is correct and what you have predicted, the more you minimize the error, the more these two will converge. And by them converging, you're training your model to perform well. So that's what this course will be about. And there's so many things. Like, it's amazing that this next word prediction, if you've used ChatGPT before, you say summarize this text. It is built, it builds on this. This is the foundation. That is the foundation. Summarization, a virtual assistance, semantic analysis, sentiment analysis. All of those use cases of large language models are built on top of this. In the next video, we're going to just talk about high level details. Yeah, we're talking about high level details in this chapter. In the next video, we're going to talk about high level details of the stages of training these. What are the stages? So let's get into that video next.